Well, that's interesting. It's out here. Mrs. Milky the Clown. She says that the word Fukushima is getting censored by YouTube. I don't know what she means by that. But, the Fukushima update, legal action to stop nuclear power in Japan, yada yada yada. Right at the end of the video, she runs these headlines for the day, and let's see. This one caught my eye. In the sinkhole, that's the sinkhole down in Louisiana. They're finding radioactive isotopes in the sinkhole. I got thinking maybe that's related to Fukushima. Yeah, maybe, it's the Fuku waft that the rain now is radioactive from Fukushima. I've seen reports of that from several people who have Geiger meters that they test whatever it is that they got rain on. You know, it's one guy, he went out with like a tissue and he swiped the windshield of his car after a rainstorm, tested that with his Geiger counter, and he got a strong reading, radiation. That was actually some months ago, but I found another video just recently, another person with a Geiger counter doing tests on the rain, and they found also the rain was radioactive. Yeah, so it seems to be the Fukushima nuclear meltdown, because the reactors that they had melt down over there, they had like a uranium reactor meltdown, they had a MOX fuel, which is mixed plutonium and uranium nuclear fuel, and that's like the absolute worst, most toxic fuel. And yeah, they had plutonium in there, and I don't know if they had like, I think they had like another type of reactor too. I think they had like a, maybe they didn't. Plutonium reactor, just plutonium. I don't know, I can't remember. I do remember that they had MOX fuel and that they had uranium fuel. And MOX fuel is mixed uranium plutonium, so you know they get the really bad nuclear fuel, that super toxic stuff. So like I know a little bit about decay, nuclear decay, that as elements, nuclear elements, as they decay, they become other elements. And so this report from E&E News that she had loaded here, or is on part of Miss Milky the Clown's video. I went out there and I read that report. I'm going to bring it up again. Oh yeah, here's another interesting finding. Butterflies have now suffered the effects of the nuclear disaster in Fukushima, and they're showing it in their genetics. Butterfly genetics are messed up right now in Fukushima. It's like 1/3 of children from Fukushima have thyroid nodules. They have like hard nodules in their thyroid. Gotta go back out to the main page here. You know what, maybe I can just go back through here. And maybe not. Okay, I'm gonna have to scroll to the bottom. There I am. And, you know what, maybe I'll just do a search for sink. Okay, here we go. More radioactive isotopes detected in latest sinkhole sample. And these are the isotopes: thallium 208, bismuth 214, lead 214, radium 226, radium 228, thorium 228. Now, when I went out there and I did a search for the decay process that results in these I found that they don't all result from the same thing. So it's not like there was a dump there of just one type of like nuclear material. You know, it's not like, oh, some nuclear plant just, you know, took some uranium-238 out there and dumped just that stuff, because like some of these come from uranium-238, but some of them don't. So it's a mix of different types of nuclear fuel, and we'll see in a minute how what it is that they have here. They could result from a couple different things. Anyhow, I wanted to show you real quick how stuff works, howstuffworks.com, how radon works, and they say that you start with a uranium-238 atom. Atom has 92 protons, 146 neutrons, half-life of 4.5 billion years. When it decays, it emits an alpha particle, leaving behind a thorium-234 atom. A thorium-234 atom has 90 protons and 144 neutrons. It has a half-life of 24.5 days. When it decays, it emits a beta particle and a gamma ray, leaving behind a protactinium-234 atom. So yeah, it's notable that while uranium-238 has a 4.5 billion year half-life, that it is constantly decaying. Every moment that it exists as a radioactive particle, it is decaying. And there might be, you know, various states, even with like 92% purity nuclear fuel, that there can be various states of the uranium-238 in there. So like various states of decay, you know, prepared to drop down to thorium. And then like everything under here is a much lower half-life. 269,000 years, 83,000 years, 1590 years. I was seeing something recently, this guy, he did some experiments. He's a big scientist guy, and the result of his experiments showed that there's a capacity to diminish radioactivity by, he says, embedding the radioactive material into a metal and then freezing the metal. Now, I would think that it would make even more sense to just to spread the radioactive material in water, because water, it expands when it freezes, and that's what you would want to do, is you want to like collapse the uranium atom in onto itself so that it's going to decay a lot faster. But yeah, this is I don't know, I haven't done any experiments to, you know, to certify that, you know, obviously water would be better to decay uranium as a freezing process. Yeah, I don't know of any other what is it called? Poly something. You know what? I'll go look it up right now. Poly-element. It's I don't know, like some plastics are like this. They are polymer. You know, I didn't find it on the screen here, but I just remembered what it was. They are a polymer, and water is a polymer. It's I don't know, poly, say like made up of more than one thing, and hydrogen and oxygen, the way they fit together, they expand when they freeze, and it's highly unusual. I don't know of any other polymer that does that. And so to embed them in metal, which is itself going to get smaller by the freezing process, that doesn't seem to make the most sense to me. And the one thing that would make the most sense to me is that you freeze the uranium in like a solution of water. So like, you know, break it down into little bits, you know, so you get a bunch of little pieces of it in there, and then freeze it in water. And it should, because it's all like it's trying to spin out a frequency. That's the radiation of it. You know, the particles of it are trying to spin out a frequency. But as the water comes down in on it and gets tight and it's still spinning, then it's bouncing into the water, and so it's like, you know, or the ice really, and you know, it's breaking down, it's losing the bits of it, you know, so it goes from being 238 to thorium 234 to thorium 230, radium 226, radon 222, polonium 218, lead 214, bismuth 214, polonium 214, lead 210, bismuth 210, polonium 210, lead 206, stable. What that means is it's not spinning so hard anymore that it's like banging itself apart, and so it'll tend to just stay together. And I don't know if you recognized in there that a couple of these elements, like lead 214, yep, lead 214, that was part of the ENE News article, lead 214. But I don't know what I didn't find in here. This is a breakdown from uranium 238. I think it was thallium 208. And if we go back to this chart, there's another chart a little bit further down the page here. I think it's not this one. Yeah, it's the next one. Okay, so from thorium 232, we get... Oh, okay, I missed... Oh, look, it goes from lead to bismuth, bismuth to thallium, thallium to lead, or it can go from lead to bismuth, bismuth to polonium, polonium to lead. Well, that's interesting. And it can go two ways. That was the first of you know, an example of that, where, you know, the radioactive decay can result in either of two types of new material. But yeah, lead is it is what used to be uranium or radon or radium or plutonium or polonium, and you know, the various isotopes of it, you know, that it be like 214 or 208 or 206, that they differ in the radioactivity of them, and they also differ in like the half-life, how long they'll last if they are radioactive. And then some of these are stable, like the lead 206, lead 207. Anyhow, I don't know, based on that little bit of research, I came to realize that very certainly the nuclear material that is in that sinkhole comes from a few different types of radioactive material. For it to be in detectable levels means that it was, you know, all of these, they're saying, you they are above the minimum detectable concentration that yeah, for them to be in a level that they can be detected in soil speaks to the soil having been polluted, that it's not a natural, it's not naturally occurring. Yeah, especially considering that some of these come from uranium. I mean, it would have to be like yellow cake there in order for there to be, you know, if there was, then, you know, presumably it would have been mined, you know, with the nuclear industry being what it is, you know, that if there was some type of really rich uranium there, it would have been dug out of the ground by now. There's all kinds of industry in that place, so, you know, certainly if they were sitting on a uranium, if they were sitting on uranium resources there, then, you know, pretty likely they would have already dug it out. But yeah, I was I was trying to find definitively, you know, where these came from, these various isotopes, but the best that I can find is that they seem to have come from nuclear fuel, the stuff that came from uranium-238, and then the stuff that came from thorium-232. I didn't figure that out. I'm gonna do a search for thorium-232 nuke power. Well, Wikipedia says that thorium-232 is the type of thorium that is found in nature. So, this thorium-228 that's there, that's not the natural kind, and then and it's in a detectable level. The thorium, or the thallium-208, that's a decay product of thorium-232, but it's not, yeah, I'm not finding anything saying that it's like associated with any type of nuclear power. Well, actually, here we go. Thorium nuclear fuel. They're saying that thorium-232 can be used, although not fissile itself. Thorium-232 will absorb slow neutrons to produce uranium-233, which is fissile. Hence, like uranium-238, it is fertile. So it could have been used as nuclear fuel, but there's not a bunch of power plants on Earth right now that use thorium-232 as nuclear fuel. So I want to find somehow, you know what, maybe thorium-232 decay, nuke power. Still coming back to uranium-233, which is not the preferred kind of uranium for nuclear power. But I wonder if there is uranium-233 in nuclear fuel in power plants, as the fuel is not entirely pure. Uranium-233, nuke power. Uranium-233 has been used as a fuel in several different reactor. So, was investigated for use in nuclear weapons and as a reactor fuel. However, it was never deployed in nuclear weapons or used commercially as a nuclear fuel. So what this is looking like is like a government dump of their test materials.